morning, everyone. It's great to see you all here. I'm Liz Cohen. I'm Dean of the Radcliffe Institute for Advanced Study, and I am so pleased to welcome you to our annual Science Symposium, which focuses our attention this year on modern epidemics. Radcliffe is Harvard's Institute for Advanced Study, and we have a twofold mission. We are dedicated to advancing deep inquiry and path-breaking research that cuts across the boundaries of traditional academic disciplines. And we are also committed to sharing this multidisciplinary work with a broad public through a full calendar of free events like today's symposium. I am especially glad to have science teacher John Ruggiero and his students from Eugene Wright Science and Technology Academy in Chelsea here with us today. If they're here, would they wave? Have they come? There they are. It's never too soon to come to an event like this. Epidemics is an ideal topic for interdisciplinary exploration. Today, we will probe challenges and innovations in epidemiology with the help of epidemiologists, data scientists, physicians, journalists, public officials, infectious disease researchers, and sociologists from across the United States and around the world. We at the Radcliffe Institute are particularly proud of our long tradition of supporting programming and research in the sciences, not only at an annual symposium like this one, but throughout the year. For example, we have an ongoing lecture series on epidemics that complements today's symposium. Last week, Dean Sandro Galea of the School of Public Health at Boston University delivered the first installment to a standing room only crowd. In the spring, we will continue the series with lectures on fibromyalgia, poverty, obesity, and Alzheimer's. For more information on these and other upcoming events, please visit the Radcliffe Institute website or take one of our calendar cards, which are available at the back of the room or downstairs at the registration table. All of Radcliffe's events are made possible by our supporters, many of whom are here with us today. And I'm particularly happy to see members of the Radcliffe Institute's Dean's Advisory Council this morning. Thank you all for your generosity, which ensures that we can continue to make our lectures, our exhibitions, our conferences like today, and many other aspects of our programming free and open to the public. Now, today's topic is urgent and timely. Our panelists will offer insights into the science and the social roots behind the epidemics that we read about on a regular basis, from Ebola, Zika, HIV/AIDS, malaria and Lyme disease, to gun violence, opioid addiction, and depression. We all come to this subject with our own perspective. As an historian, my orientation is to locate events in the larger social and historical context in which they arise. Whether an epidemic unfolds during China's Tang Dynasty or amid preparations for the Rio Olympics just last year, a society's response to a fast-spreading illness is shaped not just by the capabilities and limitations of medical science at that particular moment in time, but also by complex social factors such as race, class, gender, and religion. For an historian, epidemics can provide a revealing window into a society at a particular moment in history. Let me give you one example from our own backyard here in Boston, the smallpox epidemic in Boston of 1721. By the 1700s, smallpox inoculation had been practiced for centuries in parts of Africa, as well as in China and in India. In colonial Boston, however, the practice was virtually unheard of. That changed when an enslaved man called Onesimus told the Puritan religious leader Cotton Mather about a practice common among his tribe in North Africa, a procedure that protected him against smallpox, leaving only a small scar on his arm. A few years later, when a smallpox epidemic broke out in Boston in 1721, Mather recalled Onesimus's words, and he became an outspoken advocate for inoculation. Many white Christians in Boston mocked Mather for relying on the testimony of an enslaved man and denounced inoculation for its roots in Africa and Asia, calling it a heathen practice. Other Bostonians simply rejected the idea of deliberately infecting healthy people with a disease. By August of 1721, the controversy had become so heated that someone threw a grenade through Mather's window. The grenade didn't detonate, but Mather found a note attached to it, which read, and I quote, "I'll inoculate you with this, with a pox to you," end quote. A few Bostonians did support immunizations, including Dr. Zabdiel Boylston, who would go on to perform America's first inoculations on his own child and 2 enslaved people. But Mather's appeals were largely ignored. Smallpox spread unchecked, and by the end of the epidemic in 1722, over half of Boston's population had fallen ill. More than 800 died. The story of Boston's smallpox outbreak reveals much more than the spread of a pathogen. It is a story about racial prejudices in colonial New England, about the rigidities of Boston society, and about the forgotten contributions of enslaved Africans to American medical practice. Still today, how epidemics unfold around the world is shaped by complicated interactions between medical advancements and the social and political factors that inform and complicate the work of epidemiology. 50 years ago, many scientists considered the age of infectious disease to be over. The rise of antibiotics and vaccines was considered a triumph of modern medicine. But today, diseases we thought were gone seem to be reappearing. For example, mumps went from being common to being unheard of after the introduction of the measles, mumps, and rubella vaccine in 1971, but it has returned to Harvard and elsewhere in recent years. Other contagious diseases are also on the rise, thanks in part to globalization and global travel, environmental change, population growth, and many other factors. In addition, we are increasingly aware of non-infectious disease epidemics, often with complicated social roots. We will explore these topics during our afternoon session today with experts on guns, opioids, and mental health. With all of that in mind, I am very grateful that today's symposium will offer us a chance to wrestle with these complex issues, which are no less urgent and less challenging today than they were in 1721. Today, however, we are armed with big data, new analytical tools, new technology, and new expertise, which our distinguished panelists, I am sure, will bring to bear. Here's how the day is going to work. Professor Janet Rich Edwards, the symposium's organizer, will offer framing remarks in just a moment, and then we will dive right into the first panel. After each panel or individual speaker, we will open the floor to your questions. We'll put a microphone in the center aisle. We invite you to step up, to introduce yourself, and then to ask your question. During the lunch break, I invite you to pick up a bag lunch, which we will have available for you downstairs, and then to join us for a student poster session next door in Fay House. Students from the Harvard T.H. Chan School of Public Health, Harvard Medical School, the Faculty of Arts and Sciences, and the Division of Continuing Education will be present to share their research with you, with our speakers, and with other guests. The poster session will be open as well during the reception, which will also be in Fay House at the conclusion of today's symposium, and I very much hope you will stay and join us for that as well. Finally, I want to express my deep thanks to Janet Rich Edwards for organizing such an outstanding symposium. Janet is Radcliffe's faculty director for the life sciences, as well as an alum of Harvard and Radcliffe colleges. She is an epidemiologist with dual faculty appointments at Harvard's Medical School and the Harvard T.H. Chan School of Public Health. She also serves as Director of Developmental Epidemiology at the Connors Center for Women's Health and Gender Biology at Brigham and Women's Hospital. So please join me now in warmly welcoming Janet.
Thank you, Liz. I am so thrilled to see a full house today because this is going to be a really exciting program. I'm going to take just a few minutes to frame the agenda and give you some context for our young science of epidemiology. Chances are, when you think of epidemics, you think of infectious disease. And indeed, you'd be correct that the roots of epidemiology lie in concerns about diseases like the bubonic plague, cholera, and the flu. These diseases have long captured our imagination and our fears. Here is a 17th century painting by Flemish artist Michael Sweerts of one of the first epidemics ever recorded in history. The date is 430 BC, and we're in Athens in the middle of the Peloponnesian War. 1/3 to 2/3 of the city of Athens was struck by a strange disease, and most who became ill died. Thucydides, the historian, himself survived to describe the epidemic, a disease so severe and deadly that no one could recall anywhere its like. And naive physicians were the first to contract the disease due to their contact with the sick. Thucydides recounted tales of terrifying social upheaval, of the disappearance of social morals, because people felt they were living under a death sentence. Citizens started spending money indiscriminately. Plus, some of the poor, he noted, unexpectedly became wealthy by inheriting the property of their relatives. Gotta watch out for those nouveau riches. In fact, the disease changed history. Although the Spartans, seeing the funeral pyres burning in Athens, retreated rather than come in contact with the disease, Athens itself was weakened. Pericles, the general, succumbed and was followed by a series of weak leaders. The next offensive Athens launched was a disaster. But Thucydides was no epidemiologist. So the cause of the plague of Athens was, and still is, a medical mystery. Epidemiologists today debate what caused the epidemic, whether it was the bubonic plague, typhoid fever, or perhaps even Ebola. It wasn't until the mid-18th century before Westerners began to take a systematic look at epidemics. John Grant, here, the son of a London draper, had a native curiosity and a knack for statistics and made his way into the Fellowship of the Royal Society. He published the first analyses of the bills of mortality, London's death registry. Here's what he recorded for December 1742 to December 1743. The leading causes of death, you can see here, are convulsions, which I'm wondering if that might be heart disease, because it's so prevalent. Consumption, which of course we know of as tuberculosis. Let's see if I can see these here. Fever, no surprise. Old age. Smallpox, they apparently hadn't heard of the vaccine yet. And horribly, teeth. I think that must be a terrible way to go, frankly. Conspicuously absent are our modern diseases: cancer, only 61 deaths, and diabetes, 1 death. In fact, you were more likely to die from evil than you were from diabetes. Some exotic diseases, including, I can't read that from here, head mold shot, horseshoe head, and water in the head. And my favorite, I think the only way to go, is a rising of the lights. John Grant made these lists in an attempt to predict waves of the plague, which he didn't quite manage to do. But he's the father of the most fundamental of epidemiologic tasks, the classification and counting of disease. Some 100 years later, in London, John Grant would be followed by one John Snow, a physician. Now, the epidemiologists in the audience would be permitted a collective groan, because this story is the equivalent of our Washington and the cherry tree. This is our first known use of medical statistics to actually resolve the cause of an epidemic. It focuses on a particular neighborhood of London, which was experiencing an outbreak of cholera. At the time, the advice of the medical council was to avoid vegetables and unripe fruit, and to abstain from cold water when heated, and ardent spirits, unless, of course, habit made that impossible. In fact, boiled water and ardent spirits may have been the safest beverages in London to drink at the time. But the prevailing theory among the people of London was that cholera arose from miasma, or vapors from the Thames. This is 1854 London. And although the concept of germ theory had been proposed by Wu Yuk at the turn of the 16th century in Ming Dynasty China, in 1854 London, the germ theory of disease wouldn't grab hold for another 50 years. John Snow took it upon himself to obtain a map of the affected district and to plot every cholera death on that map. This is what we call shoe leather epidemiology, the close geographic investigation of outbreaks. The basic principle of shoe leather epidemiology is one we still use, whether we're tracing syphilis contacts, the spread of Ebola, or investigating the quintessential foodborne illness we classically call the church picnic problem. John Snow went one step further than just mapping the cases. He also mapped the lines that supplied London's drinking water through neighborhood pumps. There were two companies supplying water to the neighborhood. The Lambeth Waterworks, here in blue, drew its water upstream from the London sewage effluent in the Thames, while the Southwark and Vauxhall Company, shown here in gold, drew its water downstream from the Thames sewage. Snow traced the source of cholera to the latter, and in particular to a hand pump on Broad Street. Now, you might ask about the woman who died from cholera, though she lived next door to a pump from the cleaner Lambeth line. Turns out she'd just moved there from Broad Street and sent for water daily from the old Broad Street pump because she preferred its taste. Famously, John Snow removed the handle of the Broad Street pump and cured London of cholera. He's considered by most Westerners to be the father of modern epidemiology. Here is a map of modern London, and you can still visit the old Broad Street pump. It's now Broadwick Street, which is located right between the Anthropology store and Chipotle Mexican Grill. But the second greatest plague the world has ever known, the first was actually the Black Death, the plague itself, bubonic plague in the 14th century. The second greatest plague is the influenza of 1918, also known as the Spanish flu. It swept the globe, infecting nearly a third of all people and killing between 20 and 50 million, more than died in all of World War I. Downton Abbey fans will recall that the Spanish flu was the demise of Miss Lavinia Swine. Critics of the show complained that the entire household of Lord Grantham would have been gripped in fear of catching the disease, and dear Matthew would probably not have been quite as attentive as pictured here. In fact, the decline of infectious disease mortality due to the advent of antibiotics and vaccines in the mid-20th century is one of public health's great triumphs. You can see here that diphtheria, typhoid, and whooping cough, also known as pertussis, declined quickly due to the DPT vaccine we give children. Measles, too, is prevented by vaccine, and scarlet fever is treated by antibiotics. But we are still in the grip of contagion, including some new diseases and modern causes of mortality. Can anyone guess which one this is? Feel free to call out. And if you have a Zika, very good, this is Zika. We'll be hearing today about the Zika virus from Dr. Celina Turchi Martelli in the first panel. How about this one? No fair calling it out if you have funding. Lyme, exactly. Lyme disease. Dr. Kevin Esveld of MIT will tell us about Lyme and some provocative ways to combat it. This one, which has local issues. Here's our dear Commonwealth, 2011 to 2013, 2014 to 2016, exactly, opiates. These are deaths from drug overdose. We'll be talking about that. Dr. Andrew Kolodny will join us in the afternoon in a session devoted to epidemics with social roots. And this one. Good, gun violence. This is gun ownership. And while owning a gun does not mean you will be injured by a gun, here you can see homicides by firearms per 1 million people. We really, bad choice of words, trump everybody else in this arena. Dr. Andrew Papachristos, a sociologist from Yale, will address the application of epidemiologic principles to understand and combat the spread of gun violence. The good news is that we have new tools as epidemiologists. Through our understanding of pathogens and DNA, we now use techniques with names like molecular epidemiology and genetic epidemiology, about which you'll hear throughout the day. We also have new techniques of manipulating the genome of disease vectors like mosquitoes and mice. You'll hear about the concept of gene drive before lunch. And after lunch, a panel will address the exciting gains and the analytic challenges of big data epidemiology, where everything from the legions of bacteria in the microbiome of your guts to cell phone records can be used to trace, understand, and predict epidemics. We'll also discuss the tension between private and public sector data and the concept of open science. At the end of the day, our keynote speaker, Laurie Garrett, author of The Coming Plague and member of the Council on Foreign Relations, will address the role of international politics, of globalization and isolation in the role of countries responding to epidemics. This is CDC's list of the top 10 public health victories of the 20th century. Epidemiology, the young science, played a central role in achieving all 10 of them. After all, epidemiology is the science of public health, whether we're talking about diseases caused by pathogens or diseases with pathogenic social causes. I'm excited about the chance to learn about the coming challenges and hopefully victories of epidemiology in the 21st century. And now it's my pleasure to invite our first panel to the stage. Why don't you guys come on up, and I will introduce to you Dr. Marcia Castro. Throughout the day, we'll just give really quick introductions. You've got in your program full bios for each speaker. So Marcia Castro is an associate professor in the Department of Global Health and Population at the Harvard T.H. Chan School of Public Health and a faculty associate at the Harvard University Center for the Environment. She's published extensively on the epidemiology and control of infectious diseases, environment and health, spatial methods, and health, particularly in Brazil. Please join me in welcoming Marcia Castro.
Thanks, Janet. Good morning, everybody. Once again, thank you so much for putting together an event with such an incredible and important topic. In our first panel, we will go straight into infectious diseases in this new era of epidemics. And I think what really makes it a new era is that we're not discussing anymore of if we are going to have an outbreak. We know we will. It's just a matter of when and what pathogen is going to be this new outbreak. We live in a time that everything moves faster. People, information, goods, but also pathogens. And that makes it really challenging when we have one of those outbreaks. And in the very first moment of an epidemic, when cases are going up and everything is under chaos, we have many challenges that we have to address. How do you find those cases? How do you contain? Do you have tools to be able to treat them? How do you deliver this treatment? Do you have health systems that are strong enough to be able to be in the field, finding the people and delivering the response? We can't forget all the challenges of planning the different institutions in the government, but also different bodies, national and international, that are going to be in the field responding to this epidemic. Let's not forget also about the ethical and the legal challenges in prioritizing responses depending on the epidemic we're talking about. So there are also another phase that comes afterwards, which is when people basically say the outbreak is over, which raises the question, when is it over? Is it ever over? Which is an important one, tends to be neglected, which is to look at the aftermath. So what happens after the epidemic is not in the spotlight anymore. What are the consequences? What are the sequelae of the disease? But above all, let's look at the social, the economic, and the broad demographic impacts of the epidemic. We don't have much attention to that, but we are lucky that we do have some research groups that stay on the ground and try to bring information about this aftermath when everybody thinks it's over, but we're not quite there yet. So our panel has 3 stellar speakers that will talk a little bit about this. I'm not going to read their bios. You have in your program, and you should read because they're terrific. But I'll give you an overview of what they are going to touch upon in those issues that I briefly mentioned. So we're going to start with Dr. Crus Happi, and he's going to bring how this top-notch technology that we have now can help us in those epidemics. So he's going to talk about how genomics can be used for pathogen discovery, but also for surveillance. Then we're going to move to Dr. Annie Rimoin, who has one of those research groups that actually stay on the ground when everybody's saying it's over. And she's going to talk to us about her phenomenal work of tracking the survivors of the 1976 Ebola outbreak in the DRC and share with us some of the findings that she had about the long-term effects of the Ebola outbreak, the long-term sequelae that those people are experiencing. Then we're going to have Dr. Celina Turchi Martelli from Brazil, who played a really important role in the Brazilian response to Zika. And in the middle of all the chaos, she's going to tell us how you can actually design and conduct epidemiological studies, how you can foster collaborations between many different bodies of research, and everybody wants to come first and be the first one to say something new, and how you actually promote sharing of data. All those three issues are hard to do in normal conditions. Under an epidemic, they are way much harder. So Celina is going to tell us how she managed to do this. So together, those three different talks, we're going to walk us through three different aspects. So the first one is how we can mobilize researchers to do the right thing at the right time and generate much needed evidence to be able to respond with the right policies. Second, we're going to see how we can better track new and re-emerging pathogens, leveraging on the very best technology we have available. And last but not least, we're going to see how we can assess the long-term consequences of epidemic, largely neglected, but extremely important. So without further ado, let's get started. Dr. Happi.
Thank you, Marcia. And I also want to use the opportunity to thank the Radcliffe Institute for this invitation. So basically, I'll be talking about how we use genomics to characterize and set up a surveillance system in West Africa, and how this has helped us, and especially in Nigeria, dramatically to contain the last Ebola outbreak in 2014. So, and we do this within a framework, and that is the African Center of Excellence for Genomics of Infectious Diseases. And this center is a consortium of academic and clinical settings in Africa. But in addition to that, we have partners here, especially at Harvard, at the Broad Institute, Tulane University, and then also partnering in industry. And we work together with these partners in order to not only develop genomic technology, but also translate those high-core technologies into tools that enable us to develop rapid diagnostic tests to track, these outbreaks or to track diseases in the field. So this partnership is actually built on a very solid foundation, on a strong long-term collaboration between partners. And this partnership, because of its success, has attracted new collaborations within the region. So, and why do we focus on genomics? Basically because of one single thing, is the fact that, the whole genome project and then the sequencing of all of various organisms has brought tremendous, progress in the field of health, for instance. And Africa, really is not participating. And the lack of participation of Africa is basically due to the fact that there's no skill, there's no know-how, and then there's a huge divide between the West and Africa. And that's the reason why we just decided to use a genomic approach in order to narrow down the gap and also provide the needed, knowledge in order for African scientists to participate in the genomic revolution. So our mission actually is twofold. One is educational, as I mentioned, and that is actually to create a vibrant environment that is free of external, influence and that transcends national boundaries, in order to ensure relevant, responsive, ethical, and high-quality, genomic research in Africa. And the specific aims of the program is actually to develop, train a critical mass of well-trained African scientists to use genomic knowledge to address important issues such as elimination or eradication of infectious disease, and also to create genomic curricula on the continent to address the issue of infectious disease, and also to engage communities in prevention and public health education. And this particular aspect of this program that I'm going to be presenting, and then the achievement, is actually supported by the World Bank. But the research component of this program is supported by NIH. And the goal is actually to use field deployable, state-of-the-art technology to identify pathogens driving febrile illnesses. The reason why we talk about febrile illness is that, fever is actually a denominator for pretty much all infectious diseases in the continent. In Africa, most of the time when you go down to hospital with a fever, the first culprit is malaria. And after malaria, if you're not getting better, they say it's typhoid. And when you go through that process, if you have any other infection, then the disease progresses, and eventually you end up, in a very bad situation, or you end up dead. And we've just realized over the years that malaria is overdiagnosed, and also anti-malaria drugs are overprescribed. And that actually drives the whole process of drug resistance on the continent. And we felt that there are many other pathogens circulating around that are actually responsible for fevers that we see in 60 or 70% of African patients that find themselves in hospitals. So, and as such, the second goal is actually to create a foundation for Africans to actually carry out, very tractable research on the African continent. The reason for creating the foundation is basically because we noticed over the years that Africans are really not participating on research involving, diseases on the continent. Samples are often shipped out of Africa, and then they lose track. They have no idea of what's going on with those samples, and then the next thing they see is actually publications out. So, and it is high time that we can actually set up on the continent facilities to enable, diagnosis and enable research so that Africans can start addressing, their problems. These two programs that I just mentioned, if you see, actually cross, in one particular area, and that is the area of capacity building in the field of genomics. And what we do with these two programs is basically to just ensure that we have genomic teaching labs that we set up on the continent, develop that core diagnostic facility to track infectious diseases, and then also encourage sustainable careers among African scientists. Through this program, we've made some major progress. We've been able to add value to what happens in Africa by reversing the brain drain and also make what we call brain gain. We've been able to attract some young Africans in diaspora, returning back and working together to address these major challenges. So overall, the overall goal is actually to to build the next generation of African pathogen hunters. The reason being that because we've been playing defense in Africa, and I think it's high time to start playing offense. We've always been at the receiving end. We've heard about it. Zika, malaria, typhoid, Lassa fever, Ebola virus disease, name it. We're always at the receiving end. And I believe that now it is high time to use the knowledge and the technologies that are available to go down in the dirt bushes of Africa and hunt these pathogens, characterize them, and develop diagnosis against them before they come hunting us. I think it is high time. And that is a major goal and the ultimate goal of our program. So what are our achievements? I will take you back as just the 2014 Ebola outbreak. As far back as March 2014, when Ebola was brewing in the remote confinement of Guinea, and the world was looking away. The major health organizations were not bothered about this. We were very ambitious. I invited a group of friends of mine from Harvard, from the Broad Institute, from Tulane, and some other institutions. You could see the picture here. We sat in my lab, and we thought that we could solve the Ebola problem if it ever spread. We were very ambitious. We thought that with the little skill and knowledge that we have, we could address that major problem. But there was something that came out of that meeting, and that thing was we had a premonition that Ebola was going to spill over, and if Ebola spilled over, what could we do? We identified diagnosis as one of the major gaps. And what we did was actually to go back and start developing diagnostics, better diagnosis for Ebola, and then train people in Nigeria, Sierra Leone, and Senegal to diagnose Ebola. And as we rightly predicted, by May 20th, one of the technicians that we trained diagnosed the first case of Ebola in Sierra Leone. And subsequently, on July 22nd, I led the team in my laboratory that diagnosed the first case of Ebola in Nigeria. The fact that we were prepared and the fact that we were ready for the case of Nigeria, that single act or that single fact that we had this was very critical to avert one of the major health disasters that could have happened in the history of mankind. That is, preventing the spread of Ebola in a city of 22 million individuals in Lagos, Nigeria. We provided the result within hours, and then we activated what we call an emergency operations center and worked with the government for isolation and containment of individuals. And that alone was very critical. The other thing that we did was actually what we call self-reliance. Because we had the technology, because we believe in ourselves. So when the agencies that were parachuted in Nigeria in order to come and help control arrived, we told them that we knew what we were doing. and then we were able to contain the outbreak. Interestingly, we went on in the first 3 weeks of the outbreak, but we were able to do this basically because we've been able to achieve this fate in Nigeria because we were working on a pathogen, a category A agent like Lassa fever. And this agent is also supposed to be as deadly as Ebola. But we were actually doing this in a BSL-2 facility because we devised ways of working with these pathogens in very poor and limited resource settings. And this is what you see, what we did in Sierra Leone and in Nigeria. What we did in Sierra Leone that was unique was the fact that because we've been working on Lassa fever, when we identified the first case, we also activated what we call our contact tracing mechanism that we use for Lassa fever, And then we were able to trace the first case of Ebola in Sierra Leone to a traditional healer. We thought that he had all the power to cure Ebola, and through that process was spreading it across the region. But what we did in that process was for the fact that we were actually doing some research and then use metagenomics, for instance, as a way to understand what was responsible for fevers during the outbreak. As you can see in the diagram below, we see many of the cases that we used to come to the Ebola treatment center were not necessarily Ebola, but they were things like malaria, HIV, and everything. So what happened in the outbreak is that there's a lot of sense of panic, and everybody that comes down with fever actually is sent to the Ebola treatment center. And what happened, and then the danger and the consequence of that is that you leave your home very healthy, but then you come back, you're actually infected with the virus and then spread the outbreak. So what we also did during the outbreak was actually to convert a process that used to take a very long time in laboratory, that would take a few months in laboratory. We did that in 10 days. That is basically from collecting the sample to generate sequence data. And we were able to achieve this in 10 days. So we generated about 99 sequence data within 10 days and within the first few days of the outbreak, and made these sequences available to the international community. We were not concerned about generating data for publication. We were not concerned about fame. We're more concerned about making information available to the international community so that they can use this sequence data to generate drugs, develop vaccines, or develop diagnostics. And the publication came back months after. We also in the process, went on and worked in developing methods to sequence Ebola and then Lassa fever. And then was in collaboration with colleagues at Harvard and the Broad Institute. And this method was actually published more or less like SOPs where anybody could actually use it to repeat or replicate what we've been doing in the laboratory. And that was also very important. We used genomics actually to understand, the spread and then transmission of Ebola in Sierra Leone during the outbreak. And as you can see in this chart, you can see that you have 3 different strains of Ebola entering Sierra Leone between March and June 2014. And as you see through that process, by June 2013, the 3rd strain that actually entered SA3 has taken over. So this was a strain that was better adapted and that had a better transmission efficiency. We identified multiple SNPs in the strains, and then we could actually also confirm human-to-human transmission and also confirm the fact that there was no sources outside human-to-human transmission. Over the time, we were able to use genomic data to actually reconstitute, transmission in the region. And I don't know, this might not show, but was just a video actually to show how this happened. The outbreak in Nigeria was a little bit smaller, 4 months, but within the 4 months, we were able to actually use genomic data and then use contact tracing. As you can see in those two panels, A and B, you can actually superimpose very well, the genetic data and then the contact tracing data. And that actually shows the power of genomics actually in the field in order to understand the epidemiology and transmission of disease. So what we've been doing over the years is actually to identify pathogen based on sequences and then use these sequences as a way to develop new tools for diagnosis. And that has also been very helpful. During the 4 months of the outbreak in Nigeria, we work with partners having these sequences, or in Africa, having the Ebola sequences to generate, a rapid diagnostic test that actually could diagnose Ebola in 10 minutes. The reason why we actually spent a lot of time developing that test is basically because during an outbreak, we need 2 major things: speed and accuracy. we realized that it was taking about 4 hours to do one single diagnostics, and then we have to think about, be creative about ways of actually producing, diagnostic data almost in real time. And that when we actually did that, we actually realized that it was a major game changer in the field because clinicians could actually have this information in near real time. We also use what we also do is basically use genome data actually to understand and then discover pathogens. And in this case, for instance, we look at a patient with febrile illness, and you can see in these two panels, you see healthy patients and in febrile patients. You could see you could see that you have more in febrile patients in terms of viruses, 8%, 2% in people that are healthy. So that shows that actually the viruses actually also could be very responsible for many other febrile illnesses that we see. And in the process, because we also see some pathogens that have no heat. In this study, this is just to illustrate how we've been able to use this organism to make a major discovery, for instance, in Nigeria. And in this case control study, for instance, we discovered 2 new viruses in Nigeria. And these 2 new viruses, we actually call them the epomavirus. One, these are rhabdoviruses, similar to rabies. And these viruses show some very strong similarity to the Congo virus that was discovered in DRC Congo in 2012. And that was shown to be responsible for some kind of viral rheumatic fevers. But then that shows actually the power behind, the pathogen discovery platform that we have, because having discovered these viruses, we also went on and then developed new diagnostics for them. But what is interesting about this story is basically that when we went back to develop the diagnosis and went back to the community, even though these viruses were new, 80% of people in those communities were highly exposed and had a lot of antibodies against this virus. So it shows clearly that there are many pathogens that are circulating in our community, circulating around and we don't know about. But then we need to use technology to actually discover them and see how we can actually develop diagnosis and drugs against them. So using, again, genomic technology, we're able to understand, the origin and the spread of a very old virus in Nigeria. Not very old, but the Lassa fever virus that is very similar to Ebola in many ways. And this diagram actually shows you, and this is a study probably by Christian Anderson, a colleague of mine. And here we could show you that this virus that we call Lassa fever has been circulating in present-day Nigeria about 1,600 years ago, and circulating within Nigeria for 600 years, and then moved out of Nigeria about 400 years, moving westward. And then in the field, we can actually see the differences between a virus that is very old in one country, and then move freshly into a new country. When you look at the pathogenesis of Lassa fever between Sierra Leone and Nigeria, they are very different. We also use that to develop new technologies, but then we use the epitope that we sequence in those viruses to develop a rapid diagnostic test. We call it Contagion, and that we use that now as a way to help the Nigerian government to look at, to set up a surveillance system. What we've done over the years is not just only do science, but also to train the next generation of pathogen hunters. So we set up a genomic training program, and we do it in collaboration with Harvard. And then we started in 2014 with 11 students from 2 countries. As you can see, the list is growing over the years. And this year, we're actually 23 students from eight different countries. And here you could see, for instance, the training programs, the kind of topic that we cover. And pictures here could show very young Africans that we're training. But apart from just training them, what we train them to do is that we work with the Directorate Box Center here at Harvard to enable them to produce videos. And then these videos are actually posted and then they serve as MOOCs so that people that are not privileged to be in places like Harvard at least could have access to those videos and then learn and educate themselves. So what we've done is actually training them, but not just training them, but we also accompany them with infrastructure. So we've set up next generation sequencing in Nigeria, in Senegal, and in Sierra Leone early this year. So the trainees actually have facilities that they can go back and use. We also organize workshop and genomics workshop series in Nigeria or in Africa. And we've trained over 600 students over the past 3 years. And we have 21 doctoral students and then 46 master's degree students within the program. The whole idea is actually to translate genomic sciences, for instance, into tools that will enable us in the future, as you can see here. That is starting from a very high-tech technology, and then bring it down to a level that we can actually use in the field with small portable equipment that enable diagnostics in the field. No. So whatever we're doing actually is not stopping. What we've also done is actually to set up an outreach program. And this outreach program that we set up is actually to take it outside the university and outside the ivory tower. As you can see here, we have a program where we take it in high school and inspire the kids at the high school level. But what we also do is actually to educate science teachers in Africa, because you can't give what you don't have. So we spend time training these kids, bringing them in our labs, and then inspire them at that tender age and work with their teachers so that they can go back with biology, DNA, RNA, and protein models so that they can use that to teach. And students, we also have a summer training program that student comes in and then have training in our laboratories. We've received support from many institutions for the work that we're doing. But what we've done is actually has a lot of challenges. And one of the major challenges that we have is supply chain. Supply chain is a major problem. We're doing this kind of work in Africa, we produce nothing. So how do we maintain the supply chain? So what we do basically to maintain our supply chain is actually to convert our trainees that come to Harvard for the summer training program into courier. So we load them with luggages and then with supplies and reagents, and then when they get back, then they can take them. But then we also have problems. When you get back, then you have an issue with customs. And custom will not allow you to come in. So what we did in 2014 was actually to enable, we print them T-shirt and we say Ebola diagnostic trainee is coming back. When they got to the border and they were disturbing them, they all just saw Ebola, and then eventually custom asked them to get out of the room. So I just want to end up this presentation to thank all my colleagues and my partners here at Harvard and then all over the world. And eventually I just want to thank you again for giving me this opportunity. Thanks.
Thank you so much, Christian. This was phenomenal. So now we're going to move to the following up after the epidemic, Dr. Rimoin.
Perfect. All right. Well, thank you very much. I am here to tell you a little bit about the work that I've been doing in the Democratic Republic of the Congo. The Democratic Republic of the Congo, for those of you who are not aware, is the largest country in sub-Saharan Africa. I've spent the last 15 years of my life working on emerging viruses and doing what many people have told me over and over again was impossible, which was to do really good science in one of the most difficult places in the world. DRC, as you can see from this slide here, just to give you some context, is really big. It's a third of the size of the United States, but unlike the United States, there's only about 1,000 miles of road in the entire country, which can make it very, very difficult to get much done. The DRC is also a place where we've seen Ebola not just in 2014, but all the way back to 1976, 40 plus years ago, when the very first outbreak of Ebola that occurred both on the DRC side and in Sudan, right across the border, happened. Now, we all know today that between December 2013 and April 2016, the largest epidemic of Ebola to date generated more than 28,000 cases that we know of, and more than 11,000 deaths in the large mobile populations of Guinea, Liberia, and Sierra Leone, and just barely in Nigeria as well. This outbreak was very important and provided a lot of opportunity to track and understand survivors and generated a lot of new insights. And that's very, very important. And it's very, very important because it was also the outbreak was able to end and did not create more cases than we originally were worried about. Now, we were all thrilled when the outbreak was declared over, and but we've heard this before. The outbreak is over. The outbreak was over in Liberia, and all of a sudden there were several cases that reemerged. And since that outbreak has been over, there was actually another outbreak in the Democratic Republic of the Congo just in May. So just because the outbreak ended, this very large one, doesn't mean that Ebola isn't still there. So let's see here, how do I do this? Okay, here we go. But what we do know now is that for Ebola survivors, the outbreak isn't really over. we now know that more than 50% or so of the infected who pull through still have long-term effects. Many of these people have resumed their normal lives, but many of them are still traumatized. They're struggling to process the horrors they've seen, rejoin societies that have shunned them. And the after effects are not just psychological. We know that there are many, many after effects of Ebola. We just don't know exactly what they are. The studies that have been ongoing in West Africa have showed us just a few years after the outbreak that there are ocular side effects, there are neurological side effects, that people are actually able to carry the virus and potentially shed the virus from immune-protected sites for much longer than anybody ever anticipated. And it's interesting that nobody ever anticipated this because it turns out, there are a lot of survivors to study. What we know about right now from these studies from 2014 going forward is there are a lot of things that can happen. But the question is, what else? I think that it's important for me to invoke a little bit of baseball since the Dodgers are actually in the World Series. But it's really true that what we've learned about Ebola is that it isn't over until it's over. And the big question is when is it over? Well, and there are a lot more questions about Ebola that we still have to answer. We don't know. How long can somebody transmit Ebola virus? How long does it stay in these sites? For example, if we can still find Ebola in the fluids of the eye, are ophthalmologists at risk for acquiring infection long after survival from infection? Are survivors protected from long-term, from future outbreaks? How long does the immunity last? Is there anything that can be done to reduce these after effects? And what, aside from the clinical effects, are there? We know that there are economic effects. We know that there are societal effects. None of these things do we have any information about further than 4 years after this outbreak. Now, one would think there have been outbreaks since 1976, so we ought to have a lot of information. But actually, until this recent Ebola outbreak, the longest study looking at survivorship was only 2.5 years after an outbreak. And that was done in 1995. The 1995 outbreak, there were studies that were done 2.5 years afterwards. And much like what we've been hearing about, the outbreak happens, we think it's over, and we move on to the next thing. Well, we do have cohorts in the Democratic Republic of the Congo that are there and can provide very, very important information. In DRC, we've had 8 outbreaks, 1976 all the way through now to 2017. So what my program is doing is we're going back and looking at these survivors from 1976, 1995, and 2014. So we have 3 really unique groups that are roughly 20 years apart. And what we hope is to better understand the long-term health consequences of infection, determine if survivors develop immunity that will protect them from future infections, assess whether previously infected people can transmit the virus still. To understand all of these things that I just brought up, we really don't have any information. So we think, great, no problem. You just go, you're going to find these survivors, you get their phone number, you get their address, maybe you send them an email. No problem. Well, it's not so easy in DRC. The 76 survivors and the 1995 survivors happened before the Civil War in DRC. And so all of the records were lost. There were no records. So I went back to the original investigators from the 76 and 95 outbreaks and asked them for their notes. Well, especially from the 76 outbreak, there were no electronic records. And so I had some very, very nice help from people like Peter Piot and David Heyman, who went into their garages and their basements and their attics and found their handwritten notes. And with this information and the map that you can see up here, which was about the same as the map that still existed in Yambuku in this site, I went about the business of finding survivors. And to my surprise and to everybody else's, we found of 38 people that we knew were infected in 1976, we found 14 of them still alive in these very small villages. And so one by one, we went through the forest, found these people, and asked them if we could study them and understand their experience a little bit better. Well, the finding them is one thing, but then you have to take some samples from them. And we're not just talking about taking some blood and putting it on a dried blood spot card, or taking a couple tubes of blood and putting it in my refrigerator. You know, it takes a little bit more than that. And what I think our study site has proven is that it is possible to do really good science in very, very difficult situations. So this here is our nice little lab that we were offered by the Ministry of Health in Yambuku. And so we brought all of these supplies in this nice hut. We cleaned it up a little bit, made sure that the goats and the chickens were out of the room, and showed that it was really possible to do great science, to be able to isolate B cells and T cells, which might be able to lead to vaccines and therapeutics in these conditions. And we only have the preliminary data at this point. There's a lot more to do, but thus far, one of the very interesting things that we found is that these survivors from 40 years ago still have strong antibody responses, every single one of them. And not only that, 50% of these people had the ability to neutralize Ebola virus all of these years later. We've also found that there are evidence of long-term effects. There's a lot more work to be done, but we have just started to find out all of this very important information that has the opportunity to shed light on what these 16,000 plus survivors in West Africa may be facing, and all the other survivors from all the other outbreaks. So once we started that work, we also realized that there was a lot of questions about asymptomatic infection, about people that might get infected but never show any signs or symptoms, and how many of them existed. And over the last couple of years, with the Ebola outbreak in West Africa, we've now gotten good evidence that people who get Ebola don't always show symptoms. So I thought, well, healthcare workers are a really good population to look at. They're on the front lines, they're at greatest risk for infection, in particular in the kind of conditions that they're working in without the kind of personal protective equipment that people in this room may be used to when they go into a hospital. So we started taking samples from healthcare workers in all of these sites where there had been Ebola outbreaks and a few sites where there hadn't been, just to compare. And we found some very, very interesting results. We found that healthcare workers had very, very high rates of Ebola, surprisingly high rates of Ebola antibody, evidence that they had been previously exposed to Ebola, and much, much more so than in the sites where there had never been an outbreak reported, suggesting that not only do these people have the opportunity to get infected more often, which isn't really surprising, but that there is something going on. Now, healthcare worker is a very broad term and can mean many, many things. To most of us here, you think of a doctor or a nurse or a midwife or a lab tech. But in places like Central and West Africa, those are not necessarily the most common providers. We really, really see a lot more people going to informal healthcare workers, to what we would consider traditional healers, to pastors, to local figures who can go and help them in a way that people understand much better. They're more accessible, they're They're less expensive. They may take for payment instead of money. You could work in their fields. You can give them food that you grow yourself. So those informal healthcare workers are actually very, very important. And once again, interestingly, we found that these informal traditional healthcare providers were also people who were highly exposed. What's interesting is you think, okay, well, fine, there have been Ebola outbreaks in these sites, so it makes sense that people who were in that area at the time might have been infected. But interestingly, in Yambuku, where the outbreak happened in 1976, those people who were born after 1977, after the outbreak was declared over, and I know now we all know that over doesn't necessarily mean over, but over, those people that were born after the outbreak, we found almost as high rates of antibody in those people as the people who had been alive during the outbreak, which suggests that Ebola is still circulating in these populations long after it disappears from view. So of course now there are more questions than answers. We wonder, is Ebola virus circulating silently in DRC? Well, our preliminary results suggest that that may be the case. How are asymptomatically infected people acquiring infection? Are there certain groups that are more likely to be infected than others? Can asymptomatically infected individuals transmit the virus as well? What role do they play in Ebola transmission? And do these people also have long-term after effects? We really have no idea. And although we have known about Ebola for a very long time, we've not gotten to the bottom of these questions. The thing is we're really running out of time. The aperture for doing these studies is closing. The populations that we're working with are aging, and the natural life expectancy for a Congolese person is 57. The outbreak now happened 42 years ago, and many of these people were adults. In fact, when I started doing this study, I said I found 14 survivors. Those are the 14 survivors that we were able to collect samples from, where there were 2 other survivors that we found and made contact with, but were not able to get back to in time before they passed away. One was 95, and one was 59. So the aperture really is closing to do these kinds of studies, not just for the survivors that we know about, but for those asymptomatically infected survivors from these very, very early outbreaks. And so this is the kind of work that we are trying to move forward with as quickly as we possibly can, to gather as much information and to be able to capture samples and history and epidemiologic data, everything that we possibly can, and archive it so that as technologies improve, as we understand more about Ebola in general, not only can we make use of the samples that we're collecting now and the information we're collecting now, but that we're banking it for the future so we don't again have this problem of forgetting to look at what we should have looked at a long time ago. Thank you.
Terrific, Anne. So now we're going to move to our last speaker, Celina Turchi, who is really going to talk about how you respond to a major epidemic when you are in the middle of it.
Good morning. What a challenge to talk after the toast tea, but I would like first thank the organizers for this opportunity in name of Crus, Pernambuco, Brazil, and the Microcephaly Epidemic Research Group. I'm going here to present some insights of the public health response in the recent Zika outbreak. And I love the title of the symposium, Contagion, Exploring World Modern Epidemic, because I think that Zika was a very good example. So first, I would like to have a brief context. What are vector-borne disease in complex urban areas? So in 2015, dengue was considered a major problem in Brazil. 1.5 million cases, 900 deaths for dengue in 1 year. Since the 80s, we have been having dengue epidemics, and Brazil was one of the most affected countries in Latin America, with the 4 circulating serotypes from DEN 1 to DEN 4. So what we could say that urban environments, climate, and favors all year-round transmission of dengue with marked seasonal patterns and explosive epidemics in different areas of the country. That was the scenario for dengue and was the public health concern in 2015. But there was an alert about the introduction of another virus that were coming from the Caribbean. That was the chikungunya virus. That's an alpha virus. But this alert was just that this disease was important because it brings disability and could cause this large epidemics. That was really known. And then something comes as a mystery disease that was called by the public and by the media a mysterious disease that was a benign disease. It was a fever, like most of infectious disease. People didn't feel ill, so it was considered kind of, don't worry about this disease. Let's call it dengue-like illness. That's how doctors were thought by the public health at that moment, because we knew nothing about the neurologic context of the effects. So that's what happens. I need to go to this map just to show you actually what we had. The green circles is chikungunya, and the red circles is Zika. And imagine, in 2015, there was the Lancet journal just wrote Zika virus with a question mark following dengue and chikungunya. There was still this question mark. Was it going to occur? And if we look at the map, the alert was for chikungunya, not for dengue. The big circles in Brazil and elsewhere was for chikungunya in the Americas, not for the dengue epidemics. But here is very important to say, like we've been hearing the last speakers about Africa, Zika was known to be in Africa since 1947. But for 60 years, the epidemiology world just knew very little about it. I may say that we had 14 cases in humans published for 60 years. That was really a medical curiosity. I imagine that most infectious disease and trained epidemiologists never heard about Zika, like myself. I had never heard about my Zika. And virologists, the book virologists had just one paragraph saying about this zoonosis. But the first epidemic, the history of the epidemic, it started in Yap Island and French Polynesia Islands. But there were small population areas. There were a lot of asymptomatic cases, and the French Polynesia reported the first neurologic effect of Guillain-Barré. So if we go to that dot spot there, that's Recife, the northeast of Brazil. That's where we were at the beginning of the epidemic. It was August. So what was going on? The capital of Recife in Pernambuco, northeast of Brazil, was the epicenter of this microcephalic epidemic. We were at the front line, and there was a microcephaly with a known etiology. We didn't know what to look for because all the infectious disease and all the genetic disease supposed to cause microcephaly were negative, didn't test positive among these babies. So for that time, it was an unknown cause. And remember, when these babies are born, I mean, the mothers were affected several months before, so we couldn't get to genetic proofs at the moment to find it, nor we did have lab tests so we could test immediately. There weren't lab tests, there were lab tests in the CDC. They would take weeks to get. And even if we get them, IgM and RT-PCR aren't always positives after such a long time. So looking back in retrospective, we may say that Zika virus found a large pool of susceptible individuals, abundant presence of Aedes, good environmental conditions in a densely urban population. This is good enough, okay, to make it possible a range of possible neurological outcomes, including Guillain-Barré syndrome and also microcephaly in babies. So the timeline is almost like in old epidemics. Good doctors spot something that they see that's not usual. They contact health authorities. There's something very important going on. And in November 2015, the Brazilian Minister of Health declared situation of national public health emergency with a very few evidence. We just have short evidence, some cases, some stillbirths with virus in their brain, but there was no epidemiological study to think about causality. Causality is very important for us epidemiologists. It's a very serious business. So what I want to say is that the emergency in Brazil was a turning point for the public health response. It really was a turning point. Researchers and healthcare workers working together, they developed new protocols and research instruments for field work. The magnitude of the event, the potential expansion broke. I mean, it was so important that broke personal and institutional barriers, creating a collective solidarity feeling, a commitment of sharing data and knowledge. That was the status. Nobody wanted to publish a paper first, like said before. We want to have a group. We want to be known as a group that just could do things as a group, as a team, independently in which institutional. So I think here that I have to say the intense collaboration of several institutions around the world and within Brazil. And in this morning, I heard some very nice thoughts like epidemiology is a science of public health, and I fully agree. And that's what we saw on field exactly where we were, trying to do good epidemiology and situation. And I always learned a term yesterday, a terminology that I found it very appropriate for this moment. We were not doing peacetime research. We were doing wartime research. So time was so important. Collaboration was so important. So I want just briefly to show that was the features. We had almost like a phenotype. I can't go into details, but you can see the disproportional face and how small these children and how bad it was. Here you can see the tomography of these children. It's so easy to see the calcification and the damage of the brain and how important and how would be the development of these children considering this situation. So under this, the Ministry of Health proposed for the group, for our group, to design and do a case control study. It was funded by the Brazilian Ministry of Health and Pan American Health Organization. The idea is that epidemiologists in our toolbox, we have the case control as one of the first options because we can get from the outcome to the exposure. It means almost doing like research in reverse. You don't expect things to happen, but you just go from back going to explain. So we had many hypotheses, and two of these hypotheses were very, let's say, very important considering public health. One was that a larvicide that the government had put in the tank water that was called pyriproxyfen was the cause of the microcephaly. So this was a very important issue because during an epidemic, you would have to take out the control measure because it was supposed to be the cause of the microcephaly. And the other very important, let's say, hypothesis that came about was about vaccine. So it got really in the media that vaccine, like the rubella vaccine, was something that was doing again, kind of having epidemic, or let's say we have an outbreak due to the vaccination. So you can imagine what the panic and what the amount of confusion and rumor that was going on. So those hypotheses had to be tested. Of course, our main hypothesis was really the Zika virus infection. Why? Because it had been proven to be very neurotropic in animals. We had the right temporal sequence, and so on. So we designed a case control study. That was the first case control study designed. We couldn't get retrospectively with the kids because we had to be sure that they were congenitally infected, and we chose the right controls. And laboratory confirmation, I just brought it here because it was so important. We didn't have good lab tests. We still don't have a good lab test. And what do I mean is that Zika and dengue being from the same virus, like a same flavivirus, they cross-react. So remember that this population had been exposed to virus for 30 years for dengue. So when you get a positive serological result, you don't know if it was dengue or not. But we are very lucky to have in our institution, like you said before, preparedness, like with this lab was a reference lab for flavivirus and could do more laborious tests like PRNT just for Zika and for dengue in order to know for sure if we're having a Zika positive case or a dengue positive case. I'm just going to show that these factors, I just made a big jump and I excuse the epidemiologists. So you can see the odds one doesn't have any difference between cases and controls. So you can see here, smoking was a confounder. Actually, it was a confounder. Alcohol, vaccine, and larvicides had nothing to do with this epidemic, at least. And when we have this cartoon here, what we see in this case control, it's something very strong, a very, very power of association. Only cases had been infected or had been congenitally infected with microcephaly. So we're talking about this epidemic of microcephaly and not all microcephalies. And another very important result from this case control study, then we measured the past exposure of this Zika in the mothers of control. That would be kind of our population control. Even if it's not such a large sample size, 60% of these mothers had been exposed. What does it mean? It means that in the first wave of Zika virus, there was this huge exposures. I mean, we did have a naive population, a huge population that were struck by this wave of Zika and become infected and were infected and had antibody response. So those are published papers. The ones who work in research know this is very fast. I mean, we did it in a fast track approval that under the emergency. And so that's the situation now. And what now? You see the first map shows the first wave. when you see the first very focus points, the epidemic just in the northeast and 2 very spots in the south. And later on, in the next year, you can see that it's not too much transmission. It doesn't look like too much transmission. If we think about surveillance, we just have surveillance data for 2016. That's the red line. That means Zika infection. And we can see this peak, what we see in seasonal epidemics. And you have a plateau. The transmission, we don't see too much transmission now. Now it's chikungunya time. It's not Zika time anymore. But what we see now, is it going? This is what I found it was most surprising in the epidemic, was the use of WhatsApp for good and for bad. I mean, for good, for communication between the doctors and patients, and for bad, for rumors, for fake news, for everything you can imagine. So this was kind of a nightmare. So just brief remarks here. What were the challenges? I think there are now ongoing cohorts all over the world monitoring pregnant women and newborn babies. We know very little about the risks. I mean, if the risk is stable or we have varying risks according to different populations, we don't know very little about the spectrum of the disease we're talking about. We don't know how these children are going to develop. There's much room to improve in diagnostic for management and also for research. I think that we are in a point that we really need improvement in this kind of diagnosis. And there are other very important research being carried on. Now, I want really to thank our group here and to present our group. That's Microcephaly Epidemic Research Groups. I mean, a lot of people from many institutions, many public institutions from all over the world, and especially from Brazil. A special thanks to Dr. Laura Rodrigues from London School of Hygiene and Tropical Medicine. And here are all the institutions, and here are our supporters. NIH, there is a cohort of pregnant women with NIH, and a lot of work with Zika plan in many fields. Thank you very much for your attention.
Okay, so we're going to have just a brief discussion, and then we're going to open the floor for questions. So please start thinking about your question, because we're going to need your participation in a moment. So I think there are sort of 3 things that became pretty obvious across the 3 presentations. One is really the importance of local capacity. That's absolutely crucial. And it's not that we're solving all the problems for the next outbreak, but as you build the local capacity to respond, to have the knowledge, to have the tools, that's absolutely crucial. The second one is each one of this work is basically about overcoming challenges. And they are many, either because everybody tells you you can't work in the DRC, or because you are in the middle of an outbreak when nobody knows what to do, but you have to do something. And I think, to me, the most important thing that comes across, and fortunately this is true for many of us, is that if you really want to do the right thing in the middle of an outbreak, you really have to go against the brutal tenure system and focus about saving lives and not writing papers. And this is crucial. And some of us do that. We may get, I'm not saying what I'm going to, anyway. We may not be very successful at the end, but at least we can sleep well at night with our head on the pillow because we're trying to save lives, not to get a paper in tenure. This is crucial, and I cannot thank you enough for bringing that up. So I'm just going to have one question for each speaker, and then just to warm us up, and then we're going to open to the floor. So, Happi, I want to ask you a question. You do all this training. You have people coming from all those different countries, training there, training here in the Broad. Then those people go back to their countries. You can guarantee what goes into Nigeria. Are they able to actually build the same kind of infrastructure and have the same kind of response fast as you can provide in Nigeria. So is this training that you're providing being translated in really, resources in the countries when they go back? I wonder if you found something on sort of the social side. So how about stigma? How about social consequences in the lives of those people? And many of them have been surviving for more than 4 years. So were you able to learn something about this? And one thing that got me curious is, do we know anything if the asymptomatic infections, if those people are infectious? Because if we do have so many transmissions still going on, although everybody thinks it's over, why don't we have another outbreak? And Celina, I'm kind of going to put you on the spot, but we're both Brazilian, so I think I can do that.
Friendly fire.
So I think another thing that is obvious is context matters, always. We are never going to have 2 outbreaks that are going to be the same in the way they happen and in the way we respond to them. So I think you highlighted the importance of the frontline workers, of the government declaring an emergency, even not with so much evidence, but it did, and in supporting you to lead this incredible work, this epidemiological work to respond to the epidemic. The context now, 2017, is very different. The leadership, both in the government and in the ministry, is different. So I would like you to reflect how this whole crisis would unfold if Zika had arrived in Brazil, not in 2015, but in 2017. I told you I was going to put you on the spot. So, Christian.
Right. I don't.
You have your microphone, so go for it.
Okay. Yeah, I think one of the questions was, are there facilities for trainees to use after training, and so that they can respond as fast as we did in Nigeria in 2014? The answer is yes. Good. In one of the slides that you saw, we ensured that the trainees actually get back and use facilities. So one thing that we did basically in the countries where we have this surveillance network across the region, we've set up a reference laboratory with state-of-the-art facility, for instance. In Nigeria, we have next-generation sequences installed. We have the same in Sierra Leone. We have the same in Senegal. And those operating those systems receive the same training, and we use the same protocol for any eventuality. So pretty much, apart from using those high-end equipment, we've also translated this into medium-end and low-end facilities that it can use. For instance, for the rapid diagnostic tests, we've done extensive training for healthcare workers that can use those for diagnosis. And we also have the medium term that can use the qPCR for diagnosis for confirmatory purpose. And in Kenya, for instance, or in Nigeria, or in Dakar, you see, the very high-end equipment where we can actually do confirmation. And that is the reason why, for instance, because we have that, we've had cases in suspected cases of Lassa fever in Sierra Leone some weeks back. Those were sent to those facilities in Senegal, and actually we confirmed it wasn't Lassa fever. Presently, in my lab, we're dealing with monkeypox outbreak in Nigeria. So, and we're basically confirming cases and also responding to the outbreak and facilitating government intervention in all those areas. I think in a way we've kind of addressed that, and that's one of the reasons why we not just training, but we're also ensuring that there are facilities that will accompany the trainees.
Wonderful, thank you. And
Great. Okay, so you asked me 2 different questions. Is this mic? Okay, I think this mic's on. So you asked me 2 different questions. The first one was about the social effects of Ebola. And I just recently came back from the 1995 outbreak. So this is something that's very, very fresh in my mind right now. I spent a lot of time doing interviews and talking to these people about their experience. And I think it's very, very interesting. First of all, meeting these people and giving them the opportunity to talk, in this case, just 22 years later, it's the first time anybody had come to them in 20 years to ask them. West Africa, and this was a point that they made and really was driven home to me. In West Africa, after the outbreak, there are 16,000 survivors, And so there are support groups, there are social services, there is a huge investment on the part of the US and other governments to study them, to enroll them in trials, to enroll them in studies, which also gives them the benefit of having quality of care. Whereas people in Congo, all of these cohorts, there's nothing. There are no studies, there are no trials, there's no support. And even to go to these sites and to do these studies, in the 76 and 95 outbreaks, we needed to have labs. And we had big negotiations with the hospitals and the local government because they didn't want the survivors all in the same place. Okay. And they were worried about what happens when the survivors come. And in fact, the survivors were very nervous about coming to the hospital. They felt the issue of stigma is so great, even in trying to do studies with them, it's something that's very, very important. And so even just the fact of how hard doing these studies were is all attributable to this issue of stigma. And the stories that still need to be understood in greater detail, and we hope to do much more with ethnographic studies and really delving into their experiences so it doesn't happen again. Okay. So yes, stigma is very, very important and not explored at all. The second question you asked me about was asymptomatic infections, and you asked a very important question, which is something that we hope to be able to answer, which is, what role do these people play in transmission? And we don't know the answer yet, but we hope to learn.
Thank you. Celina?
Well, you asked me a very difficult question because prediction what could have happened if you have a different government. But it gives me the opportunity to say that when the Zika epidemic started, we were in an intense economic and political crisis. I don't know if you remember, it was under Dilma Rousseff impeachment. So it was right at the end of a period and starting a new government. And at that time, it was such an intense scientist mobilization. I mean, we were asked to write reports and to look and go to the front line to see what was going on. So it just got to the point that I think the scientists influence when they can and when the situation to take responsibility. There is nothing that you can cover in a situation like this. But I think we must be concerned about the next government that's cutting the public health, support and research funding. So we must be concerned because we're just starting to understand, the full development and the full spectrum of the disease now. And I don't think that we could say that transmission stopped and we shouldn't worry about it any longer. I think we must watch out because arbovirus, epidemiology arbovirus is changing and it's changing fast. So the first maps we saw in the world, we just have the tropical area saying the vector-borne risk population. Now it's much wider. We have different things. But just give me the opportunity also to see what the range of intervention actions were proposed since the first. They were very hard to keep for a long time. The range of interventions for the epidemic was mosquito control strategies, postponing pregnancy, travels recommendations, safe sex, and so on. So you really need to build knowledge to make these recommendations long-term possible. So thank you for giving me this opportunity to complete.
Okay, so the floor is open. Please state your name and frame your question.
Thank you. Yes, Paul Benninger, I'm at Tufts. And I want to thank you for your groundbreaking work with regard to look-backs in 76 and 95. In both the groups that you looked at, the survivors as well as the healthcare workers, What do you know about the families of the survivors and healthcare workers? Do they have titers? Do they have any histories that are suggestive of any type of communicability, particularly with close families and the intimacy and the food preparation and all the other types of activities, and of course sex with family, with spouses and the like. So the question is there anything that you know about those close contacts and families of the survivors, children, grandchildren, and healthcare workers?
Thank you. Let's take 3 questions and then we'll answer. So the next one. We'll take another question from the person behind you. Thank you.
Just real quick, I'm
Got it
James
noted.
Wilson. I'm one of the speakers in the next panel. Christian, we talked about the differences between the Nigerian experience with Ebola, which was superlative, and the Guinea experience, right? And so I think it's important to maybe raise that with the audience as to why were there tremendous differences? Because obviously the gaps in diagnostics and response and the intelligence failures that we observed in Guinea were very important to precipitate all the outcomes we saw in West Africa. And then Celina, we talked about the intelligence out of Tahiti and the emergence of Zika there, and coulda, shoulda, woulda, if we had known what was going on in Tahiti before the experience in Brazil, how could that have changed the outcomes? So again, focusing your comments on how can we improve our intel? How can we improve our ability to anticipate these kinds of problems? Thank you.
Thanks. So one more question and then we'll have the answers.
How would your role of a researcher change if you were to propose to the folks that you're trying to get the information a stipend to combat this war? In other words, you would pay them to enter the area without being harassed or freely. How
Can
would
you say your
role-
name, please?
Oh, sure. I'm not a clinician. My
That's
name is
fine.
Gladys Santiago.
Thank you. All right, so Christian, you want to start?
Okay. Yeah. The question is, what was the difference between the Nigeria and the Guinea experience in terms of Ebola response? Well, there are 2 major things. One was, yes, we understand that in the case of, infrastructure was one, but then I think what I saw there as most important in that was, in the case of Nigeria, there were 2 things. One was probably an element of luck, in the sense that when the index case arrived, the airport in Lagos, he was already sick, and he stumbled at the airport. Then at that moment, and at that time, he was probably a VIP. He was taken to one of the best hospitals in Nigeria. It also happened that at that time, the health sector in Nigeria was somehow, public health sector was paralyzed because the doctors were on strike. So he had no choice but to go to a private hospital, and he received treatment there. But the difference, though, is the fact that in Nigeria we had the ability to diagnose on the ground. In Guinea, it was the other way around. In Guinea, the samples were flown over to France and diagnosed in France, and results returned down to Conakry, and then from Conakry down to the confinements of Guinea. And that, on the average, we're taking 10 to 14 days. So within that period, then the disease was spreading. But in the case of Nigeria, we had all that it took on site. But then most importantly, it was self-reliance. The Nigerian health authority believed in themselves, unlike what happened in Guinea, where they were pretty much dictated upon. In Nigeria, for instance, when we did our diagnosis, and many of the international organizations came in with their views and their opinions, with their suggestion that they need to confirm first before we decide what to do. The Nigerian government told them, we do things the way we want. And that was a major game changer, because for a long time, if you went to the WHO website, it was still unconfirmed. But if we were going by WHO rule, we would have been in big trouble. So we were very, very self-reliant, very confident about what we were doing. And we went and then took the bull by the horn and addressed those things immediately. And eventually we were vindicated. Thank you.
Anne?
Thank you. So the question that you asked was about what do we know about long-term sequelae in family members, in healthcare workers, and what do we know about transmission, essentially. And the answer is not much yet. And I hope you're on my study section for the grant I submit. I've submitted to be able to really understand in greater detail about this. You know, one of the big issues is when you talk about asymptomatic infection is well, what does that really mean? I mean, asymptomatic infection means that we've found that they were seroreactive, but one of the questions that we did ask these people as well is, did you have signs or symptoms of anything during that time period or at any point later? Some people would remember something, some people might not. And so the question is, were they asymptomatically infected? Did they truly not have symptoms, or were they minimally symptomatic, or was it just something that was unrecognized? Because what we now know about the Ebola outbreak, or about Ebola as a disease, is that it can manifest itself in a variety of ways. It's not just the apocalyptic, hemorrhagic version that has been so well publicized. So there's a lot to understand, first of all, whether or not people actually were symptomatic, minimally symptomatic, asymptomatic, or unrecognized, and then what that will mean.
Celina?
Okay. I was asked about improved ability of seeing or detecting an outbreak. If you think about very urbanized places or environmental, in Brazil, we do have quite a public health system, and with family, let's say, practitioners, and there was a structure. So if you have those people at the front line, well aware, and knowing that if they report something, it's going to be looked at as something that's going to be investigated. I think that's the beginning of everything, of a community approach. Maybe there are some now with big data or things like this. I think I'm going to join your section just to see what you're going to say about it. But normally what we tend to see is the patient when it comes to, and someone just spots that something different or unusual in large numbers or whatever. So I feel that training, have good health workers, good community support, all those things are essential for, if we can improve this ability to see the outbreaks in a shorter time.
Universal health care, primary health care, the backbone of the SDGs. Okay. So let's get two or three more questions.
Hi, I'm John Ruggiero. I'm representing the Eugene Wright Science and Technology Academy in Chelsea, Massachusetts, in Northeastern University. My question is, you talked about a plethora of transmission factors, both environmental and genetic, in your respected epidemics. What my question is there any research, or is there any research you're aware of being done on the epigenomic factors in these disease transmissions? Thank you.
Thank you. Next one.
If Zika virus creates complications for pregnant women and birth defects for their children, what are some ways mothers can prevent this from happening?
Okay. One more, and then we're going to go to the answers.
My name is Ethel Jackson, and I just have to say, I've had a 40-year career in molecular genetics of microbes in university and in industrial settings, and I am awed and humbled by what I've heard from this panel this morning. I congratulate you and thank you. A quick question, though, going forward about how technology might help. Is there work ongoing to develop vaccines against Ebola and Zika? Do you think that is a promising approach, or do you think that it will be in the future solely up to public health and epidemiology to protect us from these diseases?
Thank you. So folks, we have 3 minutes. Let me know if you want to answer.
Well, as far as epigenomic factors involving transmission of disease is concerned, there may be some work out there, but not that I'm aware of, but it's very possible that there's work going on. But often, I think in the context in which we're working, the context of outbreak, it's very difficult at that time to sit down and then design, an experiment that will actually take into account all this, investigating epigenetic, especially in the context of Ebola or Lassa outbreak. But it's very possible that there's some work out there that I'm not aware of.
I'll respond to the question about vaccines
Okay.
and therapeutics. Certainly there have been major strides in the last several years with vaccines and therapeutics with regard to Ebola, and certainly there are candidates out there. We also believe that the people that we're working with may have very, very interesting antibodies that are developed long over time. But the bigger question that you asked was, do you think that this is the way forward? And we had a long discussion about this yesterday. And I think that while vaccines and therapeutics are very important and something that does need to be pursued, the real issue is lack of infrastructure in these countries and the ability of the people in these countries to be able to have infrastructure required to have adequate disease reporting so that people understand what's going on in real time in the places where you need to understand it most, and have the well-trained and equipped people on the ground who have the ability to respond quickly. And if you have those things, then the vaccines and therapeutics are a nice secondary response, but they are not the primary thing that will save us.
Okay, great. Celina?
Okay, prevention, I think that from now we have recommendations for pregnant women. If you go to CDC, all sites, there are preventions, and you should not, if you're planning to be pregnant, you shouldn't visit areas with the viral circulation. Without a vaccine, that's what we can do. Think about transmission by vector-borne, by a vector, by a mosquito, and by sexual transmission. So if you have a partner that visits an endemic area, so you have to have safe sex for 6 months, whatever. We don't know exactly for how long. Okay, so I think that vaccine is something to look for and to see how transmission is going to progress during the following years.
Thank you. So I want to thank all the speakers because we are right on time, so we're not going to get a red card from the organizers. Look at that. So thank you for your participation, and please join me in thanking all the speakers for really a phenomenal discussion.